Hello, today we're going to be discussing logarithms in math class. And before we started last week, we defined exponential functions and had some rules about logarithms, like anything to the 0 power is 1. We defined negative exponents and fractional exponents, and that's what we did on Wednesday. And the reason we did that is because logarithms are nothing more than exponents. Before I define logarithms, I'm going to assume whenever I'm using the letter B that it's a positive number. So any positive number except for the number 1. So more than likely you wouldn't be sitting there wondering, well, what would happen to this if that base were a 1? But we won't have that. I mean, we're not going to assume or have that happening. So here's the formal definition of logarithm. Log base b of x equals y means b to the y power is x. Logarithms are inverses of the exponential functions. We've already defined what we mean by inverse functions. That's where they switch to x and y. With a logarithm, the base is a small subscript, okay? And the exponent is just written normal size. In exponential form, the base is written large. The exponent is, what is that called, a superscript? A pi? This number to this power equals that number. For instance, can y'all see that pink? Log base 5 of 25. In order to figure out log base 5 of 25, you think to yourself, what exponent do I put on the small number in order to get this large number right here? By large, I mean just written large. The base is written small. This number here, called the argument, is written normal size. So what is it? What exponent do I put on 5 to get 25? 2. 5 squared is 25. Okay, let me write out why. Exponents or logarithms equal exponents. Okay. Now, let me see. This one's going to be kind of tricky. It's going to require you to remember something from the last time. Log base 7 of 1. Log base 7 of 1. What you're thinking is 7 to what power will give you a 1? 7 to what power gives you a 1? It goes back to something we did on Monday. Did I hear 0? Yeah, that's right. Anything to the 0 power is 1. Like 7 to the 0 power. When I say anything, I mean anything except 0. 0 to the 0 power isn't 1. 0 to the 0 power is undefined. If you punch that into your calculator, it'll even agree with me. Now, is there anything special about this 7? Is that going to be true for any number, for any base? Log base b of 1. This is our first rule of logarithms. Log base b of 1 is always equal to b to what power is 1? Well, b to the 0 power is 1. It's not just true for 7. Remember, the rule is any number to the 0 power is 1. Here's another rule of logarithms, and it's going to seem tricky just because the answer is so obviously staring you in the face. Okay? Log base b of b to the x. What exponent do we put on this b in order to get b to the x? B to what power is b to the x? No. It's one of the letters here. It's okay. What exponent do I put on this b in order to get b to the x? When it's written like that, if the bases are the same, the exponents have to be the same. B to the x equals b to the x. B to the x is b to the x. I told you it was tricky because what exponent do you put on this black b to get b to the x? Well, x. When it's written like this, you begin to realize, oh wow, if you have the same small base and large base, if these two numbers are the same, then those cancel each other out. Okay? It could also be written this way. If we had a capital B and then up in the exponent, log base b of x. If you have the same big number here and here, same big number here and base there, those are the same numbers. All of that cancels out. We're going to be doing some canceling in the first few problems here. If you have the same small base and big base, small base and big base, and you better start doing some of the problems before you decide that this is difficult after all. That's problem one. It says solve this logarithmic equation. So this is number one. X equals log base 3 of 1 over 9. X equals log base 3 of 1 over 9. Now notice how I've written it with that red 1 over there. When it says solve an equation, and that's what it says, we want to have the form x equals a number as our answer. We want just x equals a number. Well, in order to get x equal just a number and not this log base 3 right there, we're going to need to cancel out that log base 3 using this rule right here. If you have the same small base and big base, they all cancel out. Using that common base stuff that we were using the last time. I'm going to rewrite 1 over 9 with a base of 3. I'll start with the 9. 3 squared would give me a 9. But how do I get rid of this 1 over? That was some of the stuff we were doing on Wednesday. If we had like 1 over 2 to the 9th, you could write it as 2 to the negative 9th. 1 over v to the 7th, to write it without that 1 over v, you make the exponent negative. Probably we said something along the line to get rid of the 1 over, make the exponent negative. So I'll rewrite the 1 over 9 as 3 to the negative 2. And my goal is to just get x equals a number. Do I have x equals a number now? Well, yeah. Everything from this big 3 to the logarithm cancels out, leaving just negative 2. We're solving logarithmic equations. We'll be typing negative 2 in here. Okay. Number 2 says x equals log base 4. Ooh, what is that, a cube root of 16? We don't want that log base 4 there. We just want x equals a number. So what we're going to do is try to cancel out this log and little 4 by putting a big 4 right after it. So I'm going to start off with 16. How would I write that as 4 to a power? 4 to what power would give me 16? 2? Yeah. Now this is going to be something that we were doing the last time with fractional x. Oh shoot. Oh, I have to switch it over. So I rewrote the 16 as 4 squared. And now we're going to rewrite the cube root using something that we were doing the last time. The root is the denominator. The top number is the power. So we have a 4 squared. 2 is the power. The root is that denominator. It's hard to read. That's a 4 to the 2/3. And our goal is to just have x equals a number, not to have any of that log written there. If I have the same small base and large base, I can cancel all of that out. And I'm left just with that 2/3. Okay. These problems are rigged to work out. Okay? By that I mean, if you're wondering, well, wait a minute, what if that 16 had been a 15? You couldn't write 15 as 4 to a power. Or what if this 9 had been an 8? You couldn't write 8 as 3 to some power. These are rigged to work out like this. So 2/3. 2/3. Okay, problem number 3. X equals 5 raised to the log base 5 of 9. This is one of those problems where there's really no need to, there's no work to do, where you have to write. You know, sometimes in order to get answers, like if you're doing the quadratic formula, you write the problem, then scribble, you finally come up with the answer. This isn't one of those. On problem 3, it's a direct application of this rule right here. Instead of B, we have a 5, a big 5 and a little 5. A big 5 and a little 5. So all of that's going to cancel out, leaving just x equals what? 9. Okay? X equals 9. Okay, on this one, number 3, it's always going to work for you have the same big number and small number, and they cancel out. Here's another number 3, but before I do that, I should have already mentioned this. There are 2 special logarithms if you see log written without a base, if there's not the little bitty number there, you assume it's a 10. Log base 10 of x. And that's called the common logarithm. Common log. There's another one that involves a letter that y'all saw on Wednesday. Let me look for it. Where is it? Oh, I don't think I have this. The lowercase letter e denotes what's called an irrational number. It's a decimal number that never ends, never repeats. It just goes on and on. 2.71828182846 ... And it goes on, never repeating and stuff. Well, for our purposes, LNX is the abbreviation for log base e, and it's called the natural logarithm. Real life isn't so nice and neat always with integers. This lowercase, this decimal number 2.718281828 blah 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 occurs a lot when anything that grows naturally. Okay, so in nature, that's why it's called the natural logarithm. A word of warning. You're going to have to be typing in the LN eventually on Pearson. When you're typing it in, never use capital letters. Okay? If you're typing this stuff in correctly, Pearson will space it correctly and so forth. If you're typing a lowercase ln, I think a lot of times students look at this and think it's a capital I and not a lowercase l. If you start typing a capital I, it's going to get it wrong every time. Every semester, I spend hours answering emails from students that are telling me, I typed in the right answer and it says it's wrong. Well, I'll demonstrate it. The capital I looks a lot like a lowercase l, but logarithms always begin with L. And you should never be typing a capital letter on Pearson MyLab. So going back to problem 4. No, that's not problem 4. It's another number 3. I'll just do it right here. I'd hit similar. I was hoping that they would eventually get to one of this. It says x equals 10 log what? 11? Well, oh, did I have this showing when I was writing it down about the, oh, okay. Sometimes I forget to switch the screen. If I do that call out, but how does this problem 3 differ from this one over here? Well, it doesn't have that little base. It just says log, but if it just says log, you assume that the base that's there is 10. And is everything going to cancel out now? Yeah, okay, that cancels, leaving just 11. I remember years ago when I first saw these rules, I remember thinking, well, wait a minute. What if they weren't the same number? Suppose it was a big 5 and a little 6. Well, there's no reasonable time that would ever happen. And I'll show you why when we do the next problem. 11. Number 4. Let me write it down. Log base 5 of x equals 4. Same instruction, solve this equation. But I claim this problem looks different from the other ones. In the other ones, like problems 1, 2, 3, the x is already by itself. Okay? On problem 4, the x, there. On problem 4, the x is not by itself. So we need to somehow isolate that x. Well, you can't just divide like you would if it were just a number. You can't divide both sides by log base 5. But what can we do to get this logarithm to cancel? Well, we have a rule about if you have the same small base and big base, they cancel each other out. So to get this log base 5 to cancel and leave me just an x, what big number would I need to put right here that would cancel that out? What big number? 5. That's why back when I was a student wondering, well, wait a minute, what happens if the two numbers are different? There's no reason you would ever want them to be different. The only big number you would want here is a 5 to cancel that out. But if you put a big base on the left-hand side, you're going to have to do the same thing on the right-hand side. Let me try to write this so it looks a little neater. Over here, this is canceling, and we just have x equals, and this is a 5 to the 4th. Don't say 20. 5 to the 4th. Where's my calculator? 5 to the 4th would be 25 times 25, or 625. The way you punch in 5 to the 4th, you use this little caret symbol. 625. So there's really no time that you would ever want to put a, they'd always have the same numbers here. You're choosing which number to put there. Well, if you put a 3 there and there's a 5 here, it's not going to cancel. Okay? So back when I was a student wondering, well, wait a minute. What if there was a B and an A, two different numbers? Then nothing's going to happen. You just have a mess. Okay? What was that, 625? Move this out. Okay. Now there are 3 rules of logarithms that have special names. Now I'm going to write those 3 rules down, and then we're going to discuss them and do an example using all 3 of them. Okay? The first one, log base b, product means multiplication. Log base b of m times n. We can separate logarithms at multiplication by writing this as the sum of 2 logarithms. Log base b of m times n we can write as log base b of m plus log base b of n. What we're doing here is expanding the logarithm. We've gone from 1 logarithm to 2 logarithms. There's the product rule. Next, the quotient rule. In math, quotient means divide. Log base b of m divided by n. I'll put a fraction bar in red. Most people can figure out this rule having seen the first one. If you rewrite multiplication as addition, if you had to guess, we'd rewrite division as subtraction. Log base b of m minus log base b of n. So let's see, we have the product rule. Product says you can rewrite multiplication as the sum of two logarithms. You can rewrite division as subtraction. One more called the power rule. Log base b of m raised to the nth power. The power rule says if you have an exponent at the end of a logarithm, it can't just be in the middle of the logarithm. If it's at the end, you can carry it down in front of the letter L. So take the exponent, move it right here in front of the letter L, and when you write n log, that's n times logarithm. What we're going to be doing now, and don't panic, okay? In 30 minutes, this will be easy. Maybe in 20. We're going to start taking huge logarithms, something like this, and then we're going to use those properties, the product rule, quotient rule, and power rule, to do what's called expand the logarithm. To write it out where it's just a logarithm and one variable. Okay, like this one we're writing it out in with four logarithms. True, there's a lot more logarithms, but at least we can, at least it's just one variable after each logarithm. Okay? The problem 5 is the only one that's multiple choice. After this, we're going to have to start typing it in. I'm just showing you this. We're going to do another example, and we're going to see if we can look at this problem and figure out the answer, how to go from here to the answer without showing any work. Okay? We will expand logarithms. I'll just say logs. We will expand logs using the above three rules. And here's the order that we're going to go in. The first thing we're going to do, it's going to be a 4-step process. We'll use the quotient rule first. Then we'll use the product rule. Now step 3, I'm going to wait to write that down. We'll see if we can figure it out when we get to that step. And then step 4, the last thing we do is use the power rule. The power rule says if you have any exponents at the end, you can move them to the front of the letter L. Okay? I think I'd better move on to another sheet of paper. Yeah, okay, I'm going to flip it over. Here's what we're going to do. The instructions might say expand the logarithm. That's the formal name. Sometimes, like on number 5, I think it says write it as a sum or difference. Back in the olden days when one person wrote a book, all the stuff could be consistent. But here, you know, there's different people writing every one of these little problems all over the world. So sometimes it'll say expand. Other times it might say write it as a sum or difference. What did number 5 say? It just says use the properties to rewrite it. Okay, well, the formal definition of what we're doing is called expanding. And here's the logarithm we're going to expand. Log base 7 of x to the 1/2 y to the 5th over w cubed c. Okay. In 10 minutes you'll be able to do this without showing any steps. Okay? But right now I'm showing you all the steps, and this is the only time I'll show you the steps like this. I'll go through these steps only once. First thing we're going to do is use the quotient rule. The quotient rule says if you have a fraction, you can go log top minus log bottom. So right here, I'll put red. So I'm going to write it as log base 7 of x to the 1/2 y to the 5th minus log w to the 3rd c. That's the quotient rule. I'm labeling out these steps, although I'll never do it again. Okay, once I'm through with this one, we'll see if we can figure out how to go from one to the final answer without showing all these steps. The next thing to do is the product rule. The product rule says wherever there's multiplication, break it up as 2 logarithms. Addition. So it's going to be, let's see, right here's multiplication, and right there. So it's going to be log base 7 of x to the 1/2 plus log base 7 of y to the 5th. Now the red minus I'm about to write is the one that's just right here. I'm carrying it down. Now I'm going to write this as log, oops, I've already made a mistake. What did I forget to write right here after the G? The 7. Log base 7 of w to the 3rd plus log base 7 of c. Now that is the product rule. Now the third step, I didn't write out what it is. We're not ready to use the power rule yet. Looking over here, it has something to do with this minus here. What am I going to have to do with this minus for what's written there? What if I do that? What am I trying to say? It starts with a D. What am I going to have to do with this minus? Distribute the minus. Okay? That's the third step. Distribute minus. So I think I'll write it all in just one color now. Log base 7 of x to the 1/2 plus log base 7 of y to the 5th minus log base 7 of w to the 3rd, then another minus. I'm distributing the minus log base 7 of c. And we're almost finished with this. Only thing left to do is that power rule. And the power rule, oh wait, what did it say? If you have an exponent at the end, move it in front of the letter L. So just go through carrying each exponent in front of the letter L. So it would be 1/2 log base 7 of x. Then a plus, bring the 5 down, log base 7 of y, minus, move the 3 in front of the letter L. And then here on the last one, there's not an exponent at the end, so you don't move anything down there. Okay. So here's our answer. Can we come up, or do you see the pattern on how to go from here to right here? Well, what I'll say is you separate logarithms at multiplication and division. So this thing, I'm trying to go from here to here without showing these steps here. You separate wherever multiplication or division occurs. So there's 1, 2, 3, 4 logarithms. The exponent goes in front of the letter L. Now, looking at the stuff on the bottom, the W and the C, what signs do they have in front? Well, minuses. The stuff on top has pluses on top. So you separate this stuff at multiplication and division. The stuff on top has pluses in front of it. The stuff on the bottom has minuses in front of it. The exponents go in front of the letter L. Let's try to expand one without showing any steps, just to see if you get the pattern. And this one's going to be really messy. Log base 3 of a to the 1/3, b to the 1/7, c cubed, all over 7 x squared y. Separate logarithms at multiplication and division. I'm going to go through with my red pen and put little dots everywhere I see multiplication. Here, here, here. That's 7 times x squared right there. I'm also going to make my little fraction bar red. The way this gets separated, it's going to separate into 1, 2, 3, 4, 5, 6 logarithms. The stuff on top has pluses in front of it. The stuff on the bottom has minuses. How many minus signs are we going to have in this? 2, 3 minuses. The exponents go in front of the letter L. So it's going to look like I'm just writing the answer down, and that's what I'm doing. You start off with the A. Put the exponent in front of the letter L. So it's 1/3 log base 3 of A. Now I'm going to move over to the B, and I'm going to put a plus, because that B is on top. I put the exponent first. Log base 3 of b. Do y'all want to help me out with the next one? Plus or minus? I'm doing the c now. Plus. What's next? I'd write the 3, the exponent, and then log base 3 of c. The exponents go in front of the letter L. The stuff on top has pluses in front of it. Now I move down to the bottom. The 7's on the bottom, so you put a minus. There's not an exponent on the 7. So you just write log base 3 of 7. We move to the x squared. Am I going to write plus or minus? Minus, because it's on the bottom. Then I write the 2 log base 3 of x. And finally, moving to the y. Plus or minus? Minus. There's not an exponent on the y, so we don't write a number. We just write log base 3 of y. So, separate logarithms at multiplication and division. Separate logs at multiplication and division. Not at addition or subtraction. It's possible you might have some logarithms that just can't be expanded. Okay? For example, if I had this, log base 5 of x squared plus y cubed minus w. Oh, B, sorry about that. Can I do my little red dots here on this one? No. There's no multiplication and division here. What do y'all think the common thing, wrong answer, people distribute the log base 5? No, no, no. Those distributing rules don't work like this. This thing right here can't be expanded. Why? Because it's separated with addition and subtraction. It's got to have multiplication and division in order for you to do this expanding stuff. What? Oh, there. So, let's try number 5. I think number 5 is a little bit harder than number, number 6. Let me see. Let me write it down. Number 5. Log base 2 of the square root of x the 7th root of y all over what? W cubed and the square root of z. Well, at first glance, this one looks harder than the one I'd done because of those square roots and these radical symbols here. But remember, a week ago, we looked at how you take these radical signs and rewrite them. Like a 1/2 exponent is the same thing as a square root. Okay? This red square root and that red square root we can rewrite with a 1/2 exponent. Okay? A square root is the same thing as a 1/2 exponent. And what about a 7th root? I would write that with what exponent? 1 over an nth root is a 1 over n exponent. Okay, like a square root is a 1/2, a cube root 1/3, 4th root 1/4, and so forth. A 7th root 1 over 7. So there is an additional step on this one. When working with logarithms, if you see radical symbols, that's what these little red strange looking symbols are called. If you see those, you've got to first write them as fractional exponents. Then it falls out just like the ones we had been doing, or I'd done. You separate at multiplication and division. How many minus signs are we going to have in this answer? 2. How many logarithms are we going to have? How many? We separated into 1, 2, 3, 4. So I'm writing out the answer. The exponent goes first. Log base 2 of x. Now I'll move to the y. Do I put a plus or a minus? Plus, because it's on top. I brought a 1/7 and a log base 2 of y. Now let's go to the bottom. Work with the w. Plus or minus? Minus, because it's on the bottom. Write the exponent, then log base 2 of w. And one more thing, the z, plus or minus? Minus 1/2 log base 2 of z. If you look at view and example, they're going to break it up into a lot of steps. The way I did that first one, it really isn't any easier showing all those steps. I give my brother credit for it. About 10 years ago, one day he told me, I tried something in class and it worked great. Don't show every step when expanding logarithms. And I was like, no. And he said, trust me, the students can do it that way. And I was reluctantly, I said, well, okay, I'll try it. And oh, wow. Teaching logarithms went from one of the things I dreaded to one of my favorite things. Even though there's only a handful of people here right now. Okay. I'm still enjoying myself. I'm sure y'all aren't, but I am. Is B the answer here? Is that what we've written out? Mm-hmm. Okay. At this point, I have instructor tips, because when you have to start typing these in, never type capital letters or hit the space key. If you're typing it incorrectly, each log will automatically bold. Sometimes students email me and say, how do I make it bold? They're using a capital I, not a lowercase l. If it doesn't bold, then you're not typing it incorrectly. Logarithms always begin with a lowercase l, not a capital I. Notice that you have to have really sharp eyes to tell the difference between this lowercase l and a capital I. So I'll close it. This is one of those problems. There's no work to it. I'm going to separate this into how many logarithms? think about where the multiplication and division goes. Right up on top, the x squared y, that's times, isn't it? So this is going to separate into 1, 2, 3 logarithms. How many minus signs am I going to have here? Just that one for the z. To get started, you put the exponent first. 2. Now you're going to have to be typing the subscripts. No, oh, do you see what just happened? LO, as soon as I hit G, since I typed it incorrectly with the lowercase L, O, G, it's going to bold it. Let's see, what would have happened if I use capital L-O? Let's see, if I do capital L-O-G, is it going to bold and then space it? No. Okay. Never use capital letters when typing into MyMathLab. Okay. Now we got to enter the subscript B, so that's this button here, B. Then get out of that subscript, right arrow, X. And I'm finished with the X part of it. Then I'll say plus, because I'm going to the Y and it's on top, so plus, there's not there's not an exponent, so I don't put a number. Oops, no. It didn't bold. What's wrong? Well, I typed in a capital I instead of a lowercase l. And if I leave it like that, it's going to count it wrong. M-O-G. Now it's correct. Subscript B, right arrow, Y. Now, plus or minus? Minus. What number am I going to write? 4. L-O-G, base B, Z. Remember the time years ago a student said, my gosh, it takes a lot longer to type in the answer than to do the problem. And yeah, that's right. And I asked her, would you rather it the other way around? Okay. If you look at a viewing example, they have 4 parts remaining. They're going to go through all the little steps like we were doing. So they use the quotient rule, then the product rule, distribute the minus, use the power rule. Okay? What's number 7? Oh, that same thing. Okay, I'm going to write this one down. Because there's a radical sign, I want to... Number 7. Log. Hey, there's no base, so we assume it's a 10. Great. It'll be easier to type it in. Log. Ooh, is that a 7th root of S over T? Oh, look, I like these instructions. Use the properties to expand it. And then they tell you not to use a calculator. There's not a calculator could do on this one. Oh, wait, no. There. Well, we've got to rewrite it without the radical. Well, here, it's a 7th root, just like right there. So a 1 over 7 exponent is the same thing as a 7th root. So this is a little tricky. Both of these, the S and T, are both under that 7th root. So you have to put the exponent on both of them. S to the 1 over 7 over T to the 1 over 7. Because the S and T are both under that radical. if only the s had been under it, then only s would have had the 1 over 7. Let me make sure I didn't miscopy it, but I'm pretty sure it looked like the s and t were both under it. Oh, yes. So, how do we expand it? Well, how many logarithms are we going to have? 2. How many minus signs? Just 1. You get started with the exponent. 1/7 log s. Oh, I like this where there's no base that you got to be typing in, no subscript. Then plus or minus? Minus 1/7 log t. So we had to do a little bit of work just rewriting that radical with fractional exponents, like on number 5. The square roots we had to write with 1/2 exponents, the 7th roots with the 1/7 exponent. So I type in 1/7. I hit the right arrow to get out of that fraction. Log s. Notice how it's spacing it and bolding the log. Minus 1/7. Right arrow. Log t. Are y'all caught up with me? More of that same note. That instructor tip, the first time you click on a problem, it'll show it every time. But after you've clicked on it one time, it won't show it automatically. You'll have to click here if you want to read it. Okay? So number 8. There's a square root in it, so I can't just jump into the answer. I need to rewrite that square root with a fractional exponent. So number 8. Log, oh darn, it has a base, so we got to be typing it. Is that an F? Yeah. Square root of A, b to the 9th over c to the 9th. Log base f, square root of a, b to the 9th over c to the 9th. Okay. Oh. Well, there's one thing we've got to do before we start expanding it. If you have a radical symbol in it, you've got to write it with a fractional exponent first. And here we only have one radical. It's a square root. So what exponent am I going to put onto A? A square root is a square root, a 1/2. Okay. Now, if it had been a 7th root, it would have been a 1/7 cube root. So I have to write it as a to the 1/2, then b to the 9th over c to the 9th. Now, theoretically, I'm ready. I can just start typing it in. But I'm going to go ahead and write it all out. Let's see. Separate there. And there. So there's going to be how many minus signs? Just one. You start off with the 1/2 log base f of a. Now move to the b, plus or minus. 9 log base f of b. Now I'm going to the c, so plus or minus, minus 9 log base f of c. So I'm going to go 1/2 right arrow log subscript f right arrow a plus 9 log subscript f right arrow b, 20 short years, we'll be through, then a minus 9 log subscript f right arrow c. Check this answer. Any questions? Oh, here's a longer instructor tip. Never type capital letters. This is a lowercase l, not a capital I. LN, not a capital IN. If you're typing this correctly, the LN should bold. If it does not automatically bold, then you are typing a capital I instead of a lowercase l. All logarithms begin with a lowercase l. You should never type a capital I or any capital letter into Pearson MyLab. So this one has, oh, it looks horrible. But at least we don't have a subscript that we have to be entering in, okay? Let me write this one down. It just looks bad. It's not really that bad. That's an LN. Do you see why some people type in capital I? Okay. Then we have a x to the 6th square root x squared plus 1 all over x plus 1 cubed. ln x to the 6th square root x. Well, this has a square root in it, so the first thing we have to do, if there's a square root, you've got to rewrite it with a 1/2 exponent. So what I'm about to do is rewrite this messy stuff right here, putting a 1/2 exponent. Let me show you. ln x to the 6th. Now the x squared plus 1, we can't separate that. You don't separate logarithms at addition or subtraction. That's got to all stay together. And we put the 1/2 exponent right there. Notice we can't separate the x squared plus 1. Right down here, we can't separate that x plus 1. So now we're ready to try to see how do we separate it. Well, there's really only one place that there's a fraction, a multiplication dot. Where's the only multiplication going on right here? Right there? So this is going to separate into just 3 logarithms. 1, 2, 3. The x squared plus 1 and the x plus 1 have to all stay together. We get started with the 6. Then ln x. Then a plus, because you're on top. Write the exponent. And the ln x squared plus 1. Notice I'm doing the same steps I would if it had said log. Don't let the fact that it says ln scare you. It's just a different logarithm. You still do the same thing. Just like if it had said log base 2 or log base f. And now, what am I about to write? Plus or minus? Minus. We're down in the bottom. Then the 3 ln x plus 1. The only work I did was rewrite the square root as a 1/2 exponent. From there, I'm just writing out the answer. Oh, gosh. So make sure you're typing lowercase l, not capital I. 6 ln x plus 1/2, right arrow, ln x squared plus 1. If there's ever any addition after an ln, it has to be in parentheses. You've got to leave or write that x squared plus 1 in parentheses. X squared down plus 1, close parentheses, and then minus 3 ln parentheses x plus 1. Notice how I'm leaving the x squared plus 1 altogether and the x plus 1. You cannot separate those. By that I mean you can't distribute a ln as if it were like ln x plus ln 1. No. You separate only at multiplication and division. Well, in math classes, we always go one way, and then we go in reverse. But let's see, I think we have one more. Oh, same old thing. Let's see. Oh, well, the natural question is, could you go backwards? Like if you had all of this stuff, how would you go backwards? Well, the stuff that has the minuses is what goes on the bottom. The exponents are in front of the letter L. Okay? So, starting with this next one, number 10, we're going backwards. At least it'll be less to type. Let me see, what was number 10? It says log base 8 of 26. Log base 8 of 26 minus log base 8 of 5. Now, I don't know if they show a lot of steps on this on Pearson on View and Example, but I can't imagine what they would be. We're going backwards. The formal definition here is condensing. We're condensing the logarithms, going from 2 logarithms down to 1. Another way you might see it written is the instructions say write it as a single logarithm. That's your condensing. So we're going to have just one logarithm. Now there's no exponents in this. How do I know? Well, the exponents are numbers in front of the letter L, like up here. There's no exponent in front of the letter L. When I'm condensing, I always ask myself, is there a fraction bar going to be here? If we were going backwards, well, because of this minus, there's a fraction bar. The stuff that has a plus on front, or not a minus, I should say. I mean, you assume there's a plus there, right? Goes on top. The stuff that has the minus in front go on the bottom. So log base 8 of 26 minus log base 8 of 5 is log base 8 of 26 over 5. There's not a lot of work here. Oh, wait. Did I not show that, what I was doing here? Oh, I'm such an idiot. There's not a lot of work. It looks like I wrote the problem down and wrote that, so that's really all I did, isn't it? And I didn't even show you as I was doing it. Okay? But because of this minus, there should be a fraction bar. The number that has the minus in front of it, that's what goes on the bottom. So we just type log base 8 of 26 over 5. Log. Oh my gosh, you're right. I miscopied the whole problem. But we can correct it without too much trouble. That should be a 15. So I'm correcting the 15. Let me show it to you what I did. Oh. If my brother were here, he'd tell me, no, I can't do that. I got to work it out. So I put the 1 right there in front of the 5 and right there. So it's log base 8 of 26 over 15. Okay. Log base 8, right arrow, I'll do it like that, 26, oh, no, I wrote 16, 26 over 15. Oh. Number 11. Well, this one, there's really not much to do. It's all I'm going to do. If I write it down, I'm just going to write down the problem and write out the answer. So I'm going to go ahead and just start. I type in log. And the first thing I ask myself is, will there be a fraction bar? Yes, because of this minus. If this minus had been a plus, there'd be no fraction bar. But there will be a fraction bar. What goes on top? The 3 is the exponent. So the thing I'm going to type will be z to the 3rd. Now on the second logarithm, there's no exponent. So we just type z plus 8. I'm going to leave that z plus 8 in parentheses. I think it'll take it if you don't put it in parentheses. But in my opinion, if they have parentheses to start with, just keep the parentheses. Okay. Oh, wow, what did I do wrong? Oh, I didn't put the base of 5. Thanks. Log base. I was doing pretty good. I'm always forgetting those things. Okay. Now, the way you check this is to ask yourself, how would you expand it? Would it be 1 minus sign? 3 log base 5 of z, then minus log base 5 of, keep that z plus 8 all together. You can't separate the z and the 8. Let me see if I can do 12 without doing anything, without getting it wrong. Is this one that requires work, or do you just type it in? Well, there's not really anything else we need to do. So I'm going to type log, and will there be a fraction bar? Yeah, because of this minus. So up on top, I'll put the 4x plus 7. And on the bottom, I'll put the x. Since there's nothing else in that bottom, if you don't want to put parentheses, that's fine. But putting them will never be wrong. Okay? And since the 4x plus 7 is alone up there on top, if you don't want those parentheses, okay. But as a general rule, if they have parentheses in their problem, you should probably go ahead and keep those parentheses. Oh, I like this one. It's just log. You don't have that, you don't have to be typing in a base. So I'm going to get this one right. Oh, gosh. More, there's a... Okay. 1/2 ln x plus ln y. Don't type capital I-N. If you do, it doesn't bold. You go ln. Will there be a fraction bar? No. The 1/2 is an exponent. So you just write x raised to the 1/2 power. Right arrow. Oops. Get out of there. Okay. There's not an exponent on the y. You just write y. ln x to the 1/2 and y. The common mistake, sometimes students will put a plus right here. No, no, no. You don't separate logarithms at addition. Don't put the plus there. If you were going to put a symbol, it would be times, but don't put a times symbol there. That might mess up the formatting. Maybe do one more like that. Okay, how would I condense it? It'd be ln. What am I going to write? X, the 1/8 power, 1/8. Now get out of that exponent before you write the y. Now, if there'd been a minus where that plus is, you would have been going over y. But there isn't. It's a plus. Oh, gosh. Okay. Well, use the properties of logarithms to condense it. I'm just wondering, how many steps do they break this up into? Oh, my God. You see up here how many steps they have? There's 8 parts to this problem. I truly believe that sometimes it's easiest not to show the steps. Okay? So they're just going to go through it, showing these steps. No. You write log base b. Then, okay, once I've typed log base b, I ask myself, will there be a fraction bar? No. If this plus had been a minus, then there'd be a fraction bar. So there's no fraction bar. The 3 is the exponent. Don't write 3x. Instead, you write x to the 3rd. Get out of the exponent. Do not, the common mistake is right here, students will put a plus. And it's going to count it wrong. No, no, no. Because you couldn't separate it if there were a plus there. What would I write? What am I going to type in here? You only type the log once. I'll give you a choice. Am I going to type 8z or z to the 8th? Z to the 8th. Z raised to the 8th. Okay, don't put a plus. The reason you don't put the plus is if you did, you couldn't separate it like that. You can only separate logarithms at multiplication and division, not at addition or subtraction. Should we do another one like that? I mean, if I just say similar question. Oh, wait. Is this the same problem? Well, let's see. I'd go log base b. And what am I going to type? X to the 8th. And Z to the third. Don't put a plus. Okay. Any questions? Oh, more of these tips. Again, the first time you click on the problem, it's going to say that. Okay. Oh, this is another really good one. Okay. But there's no work to it. If I'm going to write it down, I just write it down and write out the answer. I start off by typing LN. Oops, what happened? LN. Now, will there be a fraction bar? Yes, because of that minus. So I put fraction bar. Now, be careful. The 2 is an exponent. So what am I going to type up there on top? X plus 8. Keep those parentheses, since there were parentheses to begin with here. Raised to the second. See, the 2 is an exponent on the x plus 8. What's going to go on the bottom? I'll give you a hint. 4x or x to the 4th? X to the 4th. See, if we had to expand that, we'd separate it at the division, put the exponent in front of the L, leave that x plus 8 together. You can't separate at addition or subtraction. And then minus, because it's x in the bottom, force the exponent ln x. Any questions? If it looks like all I'm doing is just typing in the answer, that's what I'm doing. If you want to see a lot of steps, if you want to view an example just to spite me, go for it, okay? I wonder how many steps they have on this one. Only 3, okay. Huh. Okay. No, either way. 16. Oh, this is a really good one. This is the last one where you're condensing. Starting with problem 17, it's something new and difficult. I type ln, and will I have a fraction bar here? Yes, because of this minus. The only thing that's going to be in the bottom is going to be that z term. But what about on top? Am I going to type first a 5x or an x to the 5th? X to the 5th. Right arrow to get out of that exponent. Be careful. Don't put a plus now. I'm just going to type what? Y to the 6th. Did y'all hear that? Perfect. And on the bottom, what are we going to put? Z squared. See, this uses that little rule of expanding. You separate it, multiplication and division. The exponent goes in front of the letter L. So, here. Any questions? We're through with the bulk of the assignment. There's a couple of little remnants we need to pick up about logarithms in these next 4 problems. Problem 17 says use a calculator to find the common logarithm. On most calculators, not this one right here, the only logarithm key it has is log and ln. It's only that log base 10. So in problem 17, you hit, if I haven't insulted your intelligence yet this semester, I'm about to. You hit LOG, type the 51, and when you're working with a calculator like this one, if it opens parentheses, you make sure you close it. Okay? So that's a little bit different. And we're told to round this to 4 decimal places. So let's see. How would I round this to 4 decimal places? 1, 2, 3, 4. I think this is the 10th or the 11th week? And this is the first time this semester we've had to round a number. In algebra, you don't do much rounding. But here we are. If it's going to be 4 decimal places, will I leave that as a 5 or make it a 6? Y'all remember the rules for rounding? Yeah, you make it a 6. You look at the next digit, and if the digit is 5 or bigger, you round it up. If it were 4 or smaller, you would just drop all of that. But since we have a 7 there, it's going to be 1.7076. Okay. Number 18. It says, find the logarithm using the change of base formula. You're going to get a formula to do this. Why? Why can't we just use this LOG key right here? Well, that's log base 10. Okay? And the ln is log base e. So let me write out the change of base formula. Change of base formula. It's been a while since we've had a formula. But it's black. Log. This is how you punch something into your calculator if you have a base other than base 10 or something other than an ln. You're going to use the ln key. To punch some base other than base 10 in, log base b of x, you're going to use the ln key. It's going to be ln over ln. The number that goes on the bottom is the number that's written lower. You got to remember, which number do you put on top and which number do you put on the bottom? Let me write down that problem. Oh, it's always a good thing when I start a problem with so little room remaining on a page. That means I'm not going to fill up a sheet of paper to get the answer, okay? So, number 18. How do we find log base 9 of 11? Exactly. Okay, did y'all hear that? It's going to be ln over ln. The number that's written lower, that's the little subscript, is the one. So you got to remember which number goes on the bottom. Number that's written lower. And on my calculator, when I hit ln, it opens the parentheses, so you're going to need to close them. Okay? ln 11, close the parentheses, divided by ln 9, close the parentheses. Oh, and I think it said to round to 4 decimal places. Okay. What would the 4 decimal places be? 1, 2, 3, 4. That 3, am I going to leave it as a 3 or make it as a 4? 1.0913. 1.0913. 1.0913. Now, at the beginning of the semester, it still seems like this is the beginning of the semester, doesn't it? I mentioned a free calculator that you can get on the Google Play Store or the Apple Store. It says Calc 84, and there's a way to do this without using that there. I'm not sure if it's worth the effort if you went log. Oops. Oh, wait, it's going to be bad. You have to go to log base. You go log. Oh, look at that. Can y'all see that? The way it has the little dots, little boxes. You just put 9 there. And, oops, how do I get in there? 11 there. 1.0913, blah, blah, blah. So if you have a calculator like this on your phone, you can use it on the test. Don't be taking pictures of the test, okay? But that's so, you see that's, this key takes the place of the change of base formula. But like this old calculator here, there's no key like that on there, okay? Let's see. Hey, did I even punch that in and see if I have the right answer? Yeah. Okay, one more of these. Log base 5 of 0.09. 19. Log base 5 of 0.09. I'm not going to use the phone on my the calculator on my phone because I want to demonstrate that change of base. So it's ln over ln. The number that's written lower, the subscript, is the one that goes on the bottom. Just make sure that you close those parentheses if your calculator opens them. Okay, I'll go ln 0.09, close parentheses, divided by ln 5, close parentheses, rounding to 4 decimal places, negative 1.496. Do I leave that 1 as a 1 or should I round it up to a 2? A 1? But before I punch that in, I feel like I've got to do this. What if I don't close those parentheses? I want you to see that I'm really not making it up and saying, oh, you're going to get the wrong answer if you don't close them. You see, you don't get anything close to it. You've got to be sure to close the parentheses if that's the type of calculator you have. If it opens the parentheses, you've got to close them. So, I'll show y'all that this is the negative 1.4961. Okay. And we are finished now with this calculator. Okay, problem number 20. It's the last problem in this long assignment, so it's got to be the hardest one. Not really. Let me write out a rule, about ln and e. We said that ln is log base e, and at the beginning of, I guess what you might be thinking of as this ordeal, at the beginning I'd said that if you have the same base here and here, they cancel each other out. Well, that's what ln is, log base e. So if we have an e here and here, all of that cancels each other out. Okay? It could even be written like this. If ln were the exponent, if you have e and ln side by side with nothing between them, and they cancel out, leaving whatever's left there. That's what the W is, whatever. Okay? Number 20 is really not a difficult problem. Okay, number 20. We're told f of x equals ln x. In part A, it says to find f of e to the 6th. Let me go ahead. I'm going to write down all of the parts. F of e to the ln 4. And finally, f of e to the 3 ln 4. Okay? Well, with function notation, way back when we started these functions a few weeks ago, we said with function notation, whatever's in the parentheses, you plug it in for x. So if I come over here to this black x and put in the red e to the 6th, we have ln and e side by side, so they cancel each other out, leaving us just a red 6. Okay? I'm going to go ahead and do all three of them, and then I'll punch in the answers. It just gets a little bit more involved on part B. Instead of the black X, I'm going to put all of this stuff there. We have the black ln, and then we have an E to the ln 4. Now on this one, there's actually two ways you could cancel. If the E and ln are side by side, we could cancel like that, leaving just the blue ln 4. Or we could use the way it's written right here and cancel the blue E and the blue ln. We'd be left with a black ln and a blue 4, but the colors don't really matter. You're left with just an ln 4. I think what I'll do, I'll just cancel it like that. And what's left? ln 4. And this was a big class. I mean, not in size. It's an important topic, okay? If you're a view and example person, look at this rather than the viewing example. If I replace the black x with the green, e to the third ln 4, here there's only one way to cancel. You cannot cancel the green e and the green ln 4 because there's something between them, that 3. Only thing you can cancel, the ln and e, leaving just a 3 ln 4. Okay. What do we call two functions that cancel themselves out? Starts with an I. N, V, inverse. Those are inverse functions. So let me type this in so you'll feel confident that I'm doing these correctly and not just making this up. So 6 ln 4. Oops. Look what's about to happen. You'll notice it didn't bold. I hit a capital I, and it doesn't know what's wrong. Okay? So it just sort of gives you a generic statement that basically it's saying the ln and e's cancel themselves out. But what was wrong here? I used a capital I rather than a lowercase. As soon as I put that lowercase l, you'll notice it bolds it. And what was this one? A 3 ln 4. Okay. I hate to ask this, but I've got to. Any questions? Where do you start? Okay. Let me see. So, let's see. Let's go on. Let me see. I'm on back here. Any questions? This was a big lesson, a lot of topics, but it's not that hard. How often do you have so many problems? You can just type in the answers. But like that wonderful student told me a few years ago, it takes longer to type in the answer than to do the problem. Yeah. Okay. But I guess I'll just stop recording now.